Yes, viewers, welcome back. Today we are going to look at the structural modifications of the nephron and the kidney of the animals in relation to their habitats. First of all, we should be able to understand what a nephron is. This is the basic structural and functional unit of the kidney, and it has the following parts, that is the glomerulus and the renal tubules. The renal tubules consist of the proximal and distal convoluted tubules and the loop of Henle. Now, to the structure of the nephron has the following parts. Part number 1 is what they call the afferent arteriole, which is labeled A. We have efferent arteriole, which is labeled B. And remember, the efferent arteriole is always narrow compared to the afferent arteriole. This is just to create a high back pressure for ultrafiltration within the glomerulus. C is the glomerulus. D, the proximal convoluted tubule. E is the descending loop of Henle. F, the ascending loop of Henle. G, distal convoluted tubule that normally opens into a collecting duct. Now, when you look at the kidney is always bean shaped, and you open it, you cut it longitudinally, you will be able to see these three main parts: the cortex, medulla, and the pelvis. Now, the cortex has the following parts of the nephron, that is the glomerulus, proximal, and distal convoluted tubule. So these three parts are found within the cortex, and the loop of Henle is found in the medulla. Now, the nephron is modified in various ways depending on the environment in which the animal is living. So if we have an animal living in a desert or a marine environment, it's going to have very few and small glomeruli to reduce ultrafiltration. And again, the renal tube will be very, very long so that it can increase water reabsorption. All these modifications of the nephrons here enhance water conservation in these particular organisms. For the case of freshwater organisms, they have very large and many glomeruli. This is to increase ultrafiltration, and a very short loop of Henle to reduce water reabsorption. When we go to the kidney is modified differently again depending on the environment. Having an animal with living in a desert or a marine environment, the cortex will be very, very thin because it only accommodates very few and small glomeruli, and the medulla will be very thick so that it can accommodate the long loop of Henle. Freshwater organisms have very thick or we can say very large cortex so that it can accommodate so many and very large glomeruli. Then it has a very thin medulla to accommodate the short loop of Henle. So the drawings are here. This is for the desert or an animal living in a marine environment, having a very thin cortex and a very thick medulla there. When we go to the animal living in a freshwater environment, it's going to have a very thick cortex, very large cortex. Remember, the cortex is the outer layer. Then the one painted red, this is the medulla. So this one here, it's very thin when you compare to the cortex. So that's how the nephron and the kidney are modified in various organisms depending on the environments in which they live.